Now we need to move on to the second part of our lecture, where we will start discussing the fossil fuels first, that is coal, petroleum and natural gas. So when you talk about coal, what exactly is coal? So coal is a fossil fuel and is the altered remain of prehistoric vegetation that originally accumulated in swamps or peat bogs. Peat bogs basically are wetlands. So something, or you can say organic matter or a source of carbon that has originated from these kind of areas and has taken a huge amount of time for its formation. So if you look at the formation began around 360 million to 290 million years ago. The buildup of silt and other sediments together with tectonic movements buried the swamps and peat bogs often to great depths. With burial, the plant material was subjected to high temperature and high pressures. This caused physical and chemical changes in the vegetation, transforming it into coal. So this basically the first step of coal would have been something called as peat. So the entire process would have started 350 to 360 million years ago, and from there it would have started to go inside the earth, get buried under the surface of the earth, and with high temperature and high pressures over a period of time, all the vegetable sources that you had, all the plant sources that you had, they started to convert into a form of fossil fuel, and that is something that you call as coal. Now coal basically is seen to be of four types: peat, lignite, bituminous and anthracite. Peat is the lowest quality coal and anthracite can be said to be the highest quality coal. So the quality increases in this manner. So if you look at peat, peat more or less looks like wood and it burns like wood. So that's why the efficiency that you have from peat is also very less. The amount of moisture content that peat has is very high. The amount of carbon content that it has is very less. So because of all these reasons, what happens is this is not an efficient source. Then within formation, what would have happened is if peat was subjected to more higher temperatures and pressures for a longer period of time, in that case they would have converted into a better variant of coal, that is lignite. Although again this is not a very good variety of coal, something that is although used mainly for domestic purposes, but again not seen as a very good industrial source of power. And sometimes because of its color it's also called as brown coal. Then again, if lignite would have been subjected to high temperatures and pressures, in that case it would have converted into bituminous or a better variant of coal, something that is used for industrial purposes also. And then finally the best variant that you have is anthracite. Anthracite has kind of metallic luster and it has a very shiny appearance. The efficiency that this gives is very high, the amount of carbon content is very high, the amount of residue that it leaves is very, very low. So all these are the reasons why this becomes the best variant of coal that we know about. So one by one, let's look at some of the most important parts with respect to peat, lignite, bituminous and anthracite. So if I talk about peat, the first important part is that the amount of carbon content that it has is 40 to 50%, or sometimes you'll see up to 55% probably. So if it is less than 40% or less than, sometimes called as less than 55%, then we call it peat. But essentially it should not have more than 35 to 40% carbon. If it goes beyond 40%, we usually start calling it as lignite, not peat. Then it is said to be the first step of transformation. So all the vegetative sources that would have been produced, that would have been buried under the earth, they will first have created peat. They would have converted into peat, and then peat would have converted into other forms of carbon. Then the third point is that it burns like wood with a lot of ash and a lot of smoke. So the amount of ash or smoke that is given out by peat is much higher compared to all the other variants that we are talking about. And then finally the moisture content is high, which is approximately more than 35%. So again, this also becomes a factor why it would not burn with ease or as good manner as the other varieties would. One application area that we have for peat is basically to check the oil spills. So if you have an oil spill, whether it's on land or on ocean, peat acts as a very good absorbent. It is able to absorb all the hydrocarbon which is there as crude oil on the surface of land or water, and in that case it is very helpful to check oil spills. Then the next one that you have is lignite. When we talk about lignite, the amount of carbon that it has is 40 to 55%. The amount of moisture is approximately 35%, or sometimes also said to be 20 to 35%. Because see, all these data I am giving you, if you go to varied sources, you will see varied data. But the most authentic ones have been giving the data to be 20 to 35%. Then one major problem that is associated with lignite is spontaneous combustion. Now what it means is that it has a higher capacity to form a fire accident in a given coal mine. So if you know, coal mines basically are of two types. One is underground and the other one is called as open cast mine. Now the underground mines, if they catch fire and the laborers who are trapped there, they have a very high chance that they would succumb to these kind of accidents. So lignite being the one which can undergo spontaneous combustion, it becomes a very risky business for all the miners to be inside and to do the mining for this kind of coal. And whenever you look at that there was a fire accident in a coal mine, the main reason would have been that there is a lignite presence in that coal mine. And again, as we already discussed this, that it is also called as brown coal. Application area, if we talk about, mainly it is for household or domestic purpose. Then apart from that, the next one that you have is bituminous coal. When it comes to bituminous coal, first of all, it is also known as soft coal. The carbon content is 40 to 80%. So now the amount of carbon is increasing. The moisture content is low, and mainly you will see that it would be lesser than 20%. Most of the times it will be lesser than 20%. And then a very good point about this kind of coal is that it has a high calorific value, meaning that it has a good efficiency, it burns in a much better manner as compared to the other two, that is lignite or peat. Then it is used in making coke, so this becomes one application area, and apart from that it is used in industries. Then again, it has no trace of vegetative material. So if you talk about whether it is peat or lignite and peat still have vegetative presence. The fossils on peat and lignite can be seen, but that's not the case with bituminous or even for anthracite, because there onwards you will not have any trace of these kind of material. Then you have the best variant of coal, that is anthracite. Anthracite has 80 to 95% carbon. It has negligible moisture, ignites slowly with a blue flame, so that's why it does not give any ash or smoke. There is no ash or no smoke that will be given out by this variant. So that's why anthracite becomes the most important one, and usually we see industrial applications for anthracite. The best variant of coal called as black coal, and something that we already saw, that it has a metallic luster. So if we try to look at this part, you have low rank coal and you have hard coal. Under low rank coal you can have lignite and subbituminous. Subbituminous is basically between lignite and bituminous. Then bituminous can be used for two reasons, one as thermal coal and second for metallurgical purposes, which is coking coal, and finally you have anthracite, which is the best variant of coal. In between we also have something called as steam coal, which is seen to have quality between bituminous and anthracite. Now if you look at this map, this basically gives you the states which have the coal presence. So if you look at this area, this actually is the area which has the highest amount of coal presence in India, and mainly the kind of coal that you have here is bituminous. Apart from that, Jammu and Kashmir has a presence of anthracite. Rajasthan and Gujarat have lignite presence. Even this area of Tamil Nadu has lignite presence, and the northeast mainly has peat. So all these kind of coal are present in these areas, but this is the area where you have the largest amount of coal presence in India. So that's why if you look at these three are the states which give you the highest amount of coal, starting from Jharkhand, which is having 80,176 million tons of coal. 80,176 million tons of coal. Then that is followed by Odisha, which has 75,073 million tons of coal, and then that is followed by Chhattisgarh, that has 52,533 million tons of coal. So these three are the top three states when it comes to the amount of coal production that can happen or amount of coal reserves that it has. But there is a problem also that has been seen in the Jharia coal mines of Jharkhand. The coal there has been burning for more than 100 years. It has been more than 100 years that we detected that there is an underground fire inside the coal mines of Jharia coal field. There have been rehabilitation programs that have been carried out by the government of India, but the people are not willing enough to move from there. And this is also to do with, you can say, the failure of government machinery, the way in which the rehabilitation program could have been carried out has not happened in the way they would have wanted. So all these things are associated with this, but just remember that these are the top three states when it comes to the amount of coal presence that we have in India. Now, if you talk about the entire world, India actually stands third in the entire world after USA and China in the amount of coal reserves that we have in our country. Now, the next fossil fuel that we need to discuss is petroleum. The very first thing is that you need to understand when we talk about coal and when we say petroleum, what is the main difference between the two? The main difference is actually in the way they are formed and the constituents that they have. So, for example, when you talk of coal, we talk of carbon and the amount of carbon being very, very high. But when it comes to petroleum, we don't talk about carbon but a mixture of hydrocarbons. So, a mixture of hydrocarbons that occur in the earth in liquid, gaseous or solid forms can be called as petroleum. So, now just see here, we are saying liquid, solid and gaseous. Because most of the time whenever you see petroleum, whenever you try to visualize petroleum, it's only the liquid form that you talk about. Whether it's petrol or diesel, these are liquid forms of petroleum, but you can have gaseous as well as solid forms as well. So that's why complex mixture of hydrocarbons that exist in liquid, gaseous or solid. So that's why I've written it here that often the term is restricted to liquid form, which is called as crude oil. Now, petroleum, when it comes to the formation, it is again different from how the formation of coal has happened. For example, when we talk about coal, we talk about marshy areas or land. But petroleum, the origin, if we are talking about the origin of formation, would have started underwater. So the formation would have started underwater. The sources could have been zooplanktons and algae. So vast quantities of these remains settled to the sea or lake bottoms, mixing with the sediments and being buried under anoxic conditions. When I say anoxic, it is absence of oxygen. So when you have an absence of oxygen, you call it anoxic conditions. Now, the further the layers settle to the sea or the lake bed, intense heat and pressure buildup started to happen in the lower regions. This process caused the organic matter to change first into something called as kerosene and then with more heat into liquid and gaseous hydrocarbons via a process called as catalysis, which happens due to cracking of the petroleum product, or you can say cracking of these intermediate steps. So the formation of petroleum occurs from hydrocarbon pyrolysis, in which a variety of reactions at high temperature or pressure or both. So now we need to learn some terminologies that you will see whenever it comes to petroleum. So the first thing that we have already seen is kerogen. That during the formation of petroleum, the first step that you have is kerogen. So what is kerogen? It is a solid organic matter in sedimentary rocks. So solid organic matter from where the petroleum product would be formed. Then you have something called as catalysis. So catalysis is a term used in petroleum geology to describe the cracking process which results in conversion of organic kerogen into hydrocarbons. So what exactly is cracking? So what happens is when you talk about petroleum, or specifically if I go to crude oil, something like let's say petrol or diesel, these basically have carbon chains starting from 5 up to maybe 16. So what happens is during the formation, when you are talking about the stage of kerogen or the stage before that, these hydrocarbons do not only contain 5 atoms or 16 atoms in the entire chain, but contain a lot more. So these are complex hydrocarbons, or you can say hydrocarbons with very long carbon chains. So these long carbon chains are broken up, and this breaking up of long carbon chains, or you can say conversion of complex organic matter into a simpler hydrocarbon, can be called as the process of cracking. So that's what cracking means, that breaking of carbon bonds happens and it leads to the formation of lesser hydrocarbons or hydrocarbons with lesser carbon chains. Then you have something called as pyrolysis, decomposition of organic matter at elevated temperatures in the absence of oxygen. Then two more important terms which are related to petrol and diesel are knocking and octane number. So when we say knocking basically is a sharp sound caused by premature combustion of a part of compressed air fuel mixture in the cylinder. So a premature combustion happens in the compressor that has the air and fuel mixture. So it will produce a knocking kind of sound, and this knocking kind of sound actually decreases the efficiency of the internal combustion engine. So for that very purpose we use something called as anti-knocking agents, and these anti-knocking agents have high octane number. So what octane number basically means is that if the octane number of a petrol is high, then what octane number means is that if the octane number of a given petroleum product, let's say petrol or diesel, is high, in that case what means is that knocking would be low, and that's why efficiency will be high. So what is octane number? The measure of ability of a fuel to resist knocking when ignited in a mixture with air in the cylinder of an internal combustion engine. But if you go by definition, if I talk to you about what exactly octane number means, then it is the amount of isooctane in a mixture of isooctane and heptane. So the amount of isooctane in a mixture of isooctane heptane mixture is called as octane number. Now why does it mean that if something has a high octane number, then it has a higher efficiency, it has lower knocking? The reason is that isooctane does not undergo knocking. There is no knocking that happens in isooctane, but when it comes to heptane has a natural tendency of knocking. Heptane has a natural tendency of knocking. So just imagine this, that if the amount of heptane is higher in this mixture, it means that since it is in the denominator, obviously this number will go down, and since the amount of heptane is higher, it would mean that there is knocking that is happening in the engine. So that's why the efficiency is going down. So if the octane number has to be high, it means that the amount of heptane in the mixture of isooctane and heptane has to be higher. So that's why this is what is octane number, and this is how we define it. So many a times if you look at an advertisement of a petroleum product, petrol or diesel, you will see they talk about high octane petrol or high octane diesel. So when they say high octane petrol or diesel, they actually mean that the octane number of that petroleum product, that is petrol or diesel, is high. So if it is high, it means that it will not produce knocking, and that's why it will be more efficient as compared to something that has tendency of knocking. Then next, the most important petroleum products that we know about are petrol and diesel. So what exactly do we mean by petrol and what is diesel? The first is petrol is a mixture of volatile, flammable, liquid hydrocarbons derived from petroleum and used as a fuel for internal combustion engine. So again, in a way you should say that it is a complex mixture of hundreds of hydrocarbons. Now one important thing is that when you talk about petrol, the most are saturated and contain 4 to 12 carbon atoms per molecule. Even usually we only see C5 up to C9 if it is petrol. So hydrocarbons which start from C5, or the number of carbons in the chain of that hydrocarbon is 5, or it can be as high as 9, not more than that. So this is something which will be called as petrol. Then you have something called as diesel. Petrol, another thing that you should know, is also known as gasoline. Then when it comes to diesel, combustible liquid used as fuel for diesel engines, ordinarily obtained from fractions of crude oil that are less volatile than the fractions used in petrol, and this time you have carbon chains starting from 9 and going up to 16. So this is what you will observe for diesel. Then if you go beyond 16, let's say we talk about C16 up to C25, then in that case you have naphthalene. Then if I talk about C25 to C35, here this is where you have kerosene and jet fuel. Kerosene and jet fuel are derived from here. Then if you go beyond this, you get naphthalene. If you go beyond that, then you start getting the solid form. So basically what happens is, up to C4, if number of carbon atoms in the carbon chain is up to 4, then it would be a gas. Then up to 16, it will be a liquid. Up to 25, it will be a liquid, or it will start becoming semi-solid, and above 25 you have semi-solid, and above 35 you have solid. So this is what would happen for a given hydrocarbon. Now the next kind of fossil fuel that we need to discuss is natural gas. So natural gas, basically gaseous fuel that contains very high amount of methane at small percentage of other hydrocarbons, and especially in other hydrocarbons also, ethane is the one which has the second highest amount of presence in a natural gas. Now when it comes to natural gas and petroleum, we define something called as oil and gas window. This basically is a set of temperatures as against a set of depths where you have a higher amount of or higher chances of finding petroleum or natural gas. So if you look at this, starting from the depth of approximately 4 kilometers up to 6 kilometers is something which under the temperature between 100 degrees Celsius up to probably you can say 160-170 degrees Celsius is where you have oil presence. In the same manner, starting from the same point going up to 9 kilometers and up to 225 degrees Celsius, you find natural gas. So that's why you see that oil and gas window, they coexist. So that's why many a times what you'll see is any area from where petroleum product is being extracted, the same would be the area from where natural gas also gets extracted. So most of the times you will not see there is a separate reservoir of natural gas. Instead what you will see is that it coexists with oil. So if there is an oil presence, there are high chances that area also has natural gas, and if there is natural gas, then there are chances that you will find oil also in that given area. So oil and gas window is a temperature dependent interval in the subsurface where oil is generated and expelled from the rocks. Then when it comes to natural gas, there are 4 terms that you should know about and understand what exactly they mean: LPG, LNG, PNG and CNG. Now apart from LPG, the rest three predominantly are made of methane. So whether it is liquefied natural gas or compressed natural gas or piped natural gas, they all contain methane in very high amounts. But when you talk about liquefied petroleum gas or LPG, LPG mainly contains butane, small amounts of propane, and even smaller amounts of propene and butene. So these four majorly make the LPG. If it is a tropical country, the amount of butane will be high, and if it is a temperate or a polar country, then amount of propane can be higher. So that's why when you talk about India, in India what you'll see is that in all the gas cylinders that we are getting, that has large amount of butane and very less amounts of propane and other gases. In the temperate countries and in the polar countries, you will see that even though what will happen is the amount of butane will remain high, but the amount of propane as compared to tropical countries like India will be higher. Now one more thing when it comes to liquefied petroleum gas or LPG, when you talk about propane or butane, these basically are gases which are colorless and odorless. But whenever you switch on the gas stove, it's not that you do not smell anything, you do smell something. And that smell, that pungent smell that has been provided is for this very reason, that if there is a leakage, a person should come to know about it. So that smell that we are talking about, this smell does not come from butane or propane. That smell actually comes from something called as ethyl mercaptan. So ethyl mercaptan is mixed with LPG so that it would give an indication if at all there is a kind of leakage that is happening in a given gas cylinder or wherever it is being used. So that's why just remember this, from prelims point of view, these kind of small things can sometimes be important for the examination. Now then you have something called as liquefied natural gas. So when I say liquefied natural gas, it is a natural gas that has been cooled to a liquid state at about minus 160 degrees Celsius for shipping and storage. So why, see, if you talk about a natural gas is what? Is gaseous. So since it is gaseous, it will take more amount of space and carrying it will become very, very difficult. But if we are able to compress it, and we compress it into a liquid form which can be stored and which can be transferred or transported, then in that case it becomes very easy for us to carry on the operations. So that's why this natural gas will be converted into liquefied natural gas and then it will be transported wherever you want it to. Then apart from that, you have something called as compressed natural gas. So when I say compressed natural gas, it refers to methane that is stored at high pressure and is a fuel which can be used in place of petrol, diesel and LPG, a cleaner fuel as compared to the fuels mentioned above. So as you compare to petrol or diesel, obviously CNG is a much cleaner fuel. We have seen this in Delhi, that in Delhi we started to remove all the petrol and diesel public vehicles and we started introducing the CNG cylinders which are being used extensively by the auto rickshaws and other transport facilities. So this is what CNG is, compressed natural gas. Again, this basically is formed of methane. Then you have something called as piped natural gas. Not very common in India, not very popular in India, but even though seen at various places, if you see in Mumbai, Gurgaon, NCR region, all these are regions where piped natural gas is being provided. So what is piped natural gas? Natural gas or a form of methane that is being provided to the household for domestic purposes. So instead of carrying or providing gas cylinders, now there will be a central facility that will contain piped natural gas, and through the pipelines each and every household in that locality will be provided the piped natural gas for the domestic consumption. So this is what piped natural gas is. Then again very similar to CNG, and only difference is that it is supplied through pipelines for household uses. Again, as I've already said, that all these three primarily are made of methane. The main constituent for all these three is methane. Now when it comes to fuel gas, and by fuel gas I mean any gas that can be used as fuel. So any fuel gas basically can be divided into two kinds, manufactured and natural. When I say natural, what we actually mean is that we are not making many changes in the original structure of the gas. So in that case, when you talk of propane or butane, or you can talk of methane also, these can be called as natural gas because you do not make much change in their original structure and the original mixture. Then when it comes to natural gas, these kind of gases are required there, that is coal gas, water gas, producer gas, syngas and wood gas. So what you should know is, from prelims point of view, what are the main constituents of the given mixture, right? So this is coal gas, water gas, producer gas, syngas and wood gas. So let's try to see what exactly do they mean and what are the main components of each of these manufactured gases. So the first is coal gas. When it comes to coal gas, it is obtained when coal is heated strongly in the absence of air. So if you heat coal in the absence of air, then you get coal gas. Then again, water gas is a mixture of carbon monoxide and hydrogen produced from synthesis gas. So a mixture of carbon monoxide and hydrogen. Then you have producer gas. Producer gas is a fuel that is manufactured from materials such as coal as opposed to natural gas. So burning of coal is providing you producer gas. Then again you have something called as syngas, or sometimes also called as synthetic gas. Syngas or synthetic gas, a fuel gas mixture consisting primarily of hydrogen, carbon monoxide and very often some carbon dioxide. So that is where you have one difference from water gas. Syngas is usually a product of gasification and main application is in electricity generation. Can be produced from many sources including natural gas, coal, biomass or virtually any hydrocarbon feedstock. What is feedstock? Basically you can say, in other words, any raw material for a given thing is called as feedstock. So by reaction with steam, which is called as steam reforming, by reaction with carbon dioxide, which is called as dry reforming, or by oxygen, which is called as partial oxidation. So all these three processes can produce syngas. Then you have wood gas, which is a syngas fuel which can be used as a fuel for furnaces, stoves and vehicles in place of gasoline. That is, gasoline is the other word for petrol, diesel or other fuels. So these are what manufactured gases are. Most importantly, remember what they are made of. That's the most important part. And secondly, industrial application. These are the two areas from where if they ask a question, this is where they can ask from. So with this we come to the end of coal, petroleum and natural gas, meaning the conventional sources of energy or fossil fuels. Now the fact is, we know for sure that fossil fuels are not going to last for long and we cannot be dependent on fossil fuels for all our needs. Right now that is the case, we cannot help that. 75% of all the electricity that is being produced in India currently is through coal or thermal power plants which are using coal. So all the other sources of energy, whether you talk about hydroelectricity, wind energy, solar energy, all that combined is just, or nuclear energy also for example, all that combined is giving us just 25% of power production and 75% is coming only from coal. And given the fact that these are fossil fuels which will not last forever, we need to start using all the alternate sources of energy. We need to start thinking about the fact that we need to curb the use of these kind of fossil fuels. And we have taken many measures in that form and we have been trying to make sure that all the other sources of energy are being used more and more in the coming years. So all that is associated with it. We have concluded with all the static areas that were related to these areas. I hope that you are going through the current affairs, the webinars that are being conducted. There are a lot of things that are happening in the energy sector. I would prefer that each one of you go through all the webinars of science and tech that have happened, or the webinars of environment and ecology that have happened, because we have covered many areas there as well. So with that I will end the lecture here. This was the first part. We'll start with the non-conventional sources of energy or the renewable sources of energy next.